So this first question asks you to graph. So it asks you to draw a picture that represents what's going on with this, what they call a compound inequality. So already we've got something it's got some layers to it that we're having to peel off. So before we get to the word compound, and the good news is we're not going to really wrestle with compound inequalities until we level up a little bit. Right, so our second run through the material, we'll talk more about compound inequalities. Right now I want to focus a little bit more on the graphing and a little bit less on the compound part of this problem, but we'll talk about them both just so that we can get an initial exposure. Let's suppose that I just had this problem. Graph the inequality x is less than or equal to -2 on the number line. How would you do that? What kind of a picture would you draw, Joe?
To graph -2.
Okay, so you start by graphing the number -2.
And you put circle it, and then don't you shade it in a little because it's less than or equal to.
Okay, so you put in a circle here at -2 on the number line, and it's a closed circle because, as you say, the inequality permits for less than or equal to, right? So that's what this symbol here means, less than or equal. And so the number -2 itself is actually a part of our set. That's why we put a closed circle, a solid circle right there. And then how do we convey the less than in our picture? Where are the numbers on the number line that are less than -2?
Just drag the whole line going to the left.
Yes, exactly. All the numbers that are less than -2, less than means to the left on the number line. Okay? So that means that to graph the inequality, we're just going to shade everything that is less than, everything that is to the left of -2 on the number line. So if the question were just to graph the inequality x is less than or equal to -2, I would draw a picture that looks like this. I would fill in a circle, a solid circle here at -2, and then I would shade everything on the number line to the left. So that's for the first piece. Again, the equal to explains the solid circle. The less explains why we shaded everything to the left. All right. So now imagine that that weren't the problem, but that this were the problem. X is greater than or equal to 5. Let's suppose we want to shade that, graph that inequality on the number line. So what would I do different here? Where would I start, Jerry?
Go to 5.
Go to 5.
Do the same thing and just go to the right.
Same thing, and I want a solid circle because what does this symbol in between x and 5 here mean? How do we read that? X is greater than or equal. Right. Greater or equal. And because of the equal part, we're going to put in a solid circle because 5 is actually included in this set. And greater than means we're going to shade which direction? Right, instead of left. After all, greater means to the right on the number line. So that's how we understand what the word greater looks like. So I'll start at 5 with a solid circle, and then I'll shade everything going to the right. So we now kind of understand how to do each one of the pieces in this problem. If I want to visualize x is greater than or equal to 5, I'll draw this blue segment. If I want to visualize x is less than or equal to -2, then I'll draw this orange segment. And so the fun part comes in, and this is something I just want us to taste right now, and we're not going to really get an entree plate worth of this until later in the semester. But just as a taste, I have the word or in between these two inequalities, which means I don't want there to be two different answers to this problem. I want there to be a single answer. So how am I going to take these two sets, the orange set and the blue set, and combine them together into a single set? What is that single set going to look like? What should I be shading if I want my answer to include the result of ORing together, x is less than or equal to 2, or x is greater than or equal to 5? What do you think? What are some possibilities? If I say it's raining or snowing, then is that a true statement if right now it's raining outside? Yeah. If it's raining right now, then that statement is true. Right? What if it's snowing right now? If right now it's snowing, then is the statement it's raining or snowing true? Yeah, it's also true. So what does it take to make an or statement true? Just one or the other of the pieces has to be true. Right? It either has to be raining or it has to be snowing. If either one of those two are true, then this red statement is a true statement. So if I'm taking two sets and I'm putting them together with an or, then what I get in the combination is I'm going to get everything that either belongs to the orange set or belongs to the blue set. So I'm going to get all the numbers that are less than or equal to -2 are going to be a part of my answer, but so are all of the numbers that are greater than or equal to 5. So, and again, we're going to get a much bigger taste of this later on, when we OR these two intervals together, these two inequalities together, what we're going to do is we're just going to take everything. Take everything that resides, everything that resides in either set. Residing in either set. And so, the orange piece, the x's that are less than or equal to -2, becomes a part of my answer. So I'm going to include a piece in my final answer that shades -2 and everything to its left. But then, likewise, I'm also going to include everything which is greater than or equal to 5. And so my final answer will also include the number -5 and everything which is to its right. So the final answer to this problem that asks us to graph this compound inequality is going to be that red sketch on the number line. So we found each one of the pieces individually, we graphed them individually, but then our final answer has to be a single sketch. And because we're ORing these two intervals together, that single sketch has to include everything that resided in either of the two original pieces.